Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see what is AWS EKS, which is Elastic Kubernetes Service. So this EKS is managed Kubernetes service by AWS Cloud, and in this video, we're going to understand the basic architecture of EKS. So what are the various components in EKS architecture? And in the coming videos, we'll understand in how many ways we can set up EKS and the other tools and utilities necessary to talk to AWS EKS service. So in cloud managed clusters, so we'll not manage any of the servers or will not manage Kubernetes. So everything will be managed by your cloud itself. So basically it is a shift from our self-managed Kubernetes clusters to cloud managed Kubernetes clusters. Before understanding AWS EKS, let's briefly go through some basic concepts in Kubernetes. So we all know that Kubernetes is also known as K8s, which is an open source container management tool. It provides container runtime, so you can switch this container runtime as we already seen in our Kubernetes series. And it also provides container orchestration, self-healing mechanism, service discovery, load balancing across all the available instances or pod replicas, and also how to scale the containers and descale them. Initially, it is developed by Google for managing their containerized workloads, but later donated to CNCF. This entire Kubernetes is written in GoLang. Kubernetes may have multiple moving parts, and there are multiple ways of configuring them, coming to the various components necessary to set up the cluster, and providing the networking between the pods, and the CLI tools necessary to talk to these clusters for deploying applications and managing them. So Kubernetes is not easy to deploy, so there are multiple components. And coming to the K8s architecture, we have two types of nodes. One is the master node, the other one is the worker node. As we already see in our Kubernetes series, the master node will have components such as Kube API server. So this is like an API endpoint. You can say that it is an entry point to your complete Kubernetes cluster. So the external tools like kubectl or any third-party tools, if they want to talk to the Kubernetes cluster, they need to talk to the API server first. And coming to the other component, we have HCD, which is a distributed key value store, which stores complete information about the cluster. And then we have controller manager, which controls various states inside the Kubernetes cluster, managing the replicas, managing the endpoint. So there are a lot of controllers present, and those are all managed by their own controller manager. And we have scheduler. So basically scheduler will decide where should your pod be scheduled onto. Let's say if you have 10 different worker nodes, the scheduler finds the best node for your workload and then schedules it onto that particular node. And we have also kubectl, which is a command and utility that talks to the Kubernetes server. And coming to the worker node, so inside the worker nodes you have kubelets, which are acting like an agents. So they talk to the Kubernetes API server, and also they receive information from the API server for creating the workloads. So workloads in the sense, these are basically pods. And also we have container runtime, so like Docker, CRI-O. So there are multiple container runtimes, so you can use your own container runtime of your choice. And also you have kube proxies. So these are the networking proxies that helps in setting up the networking rules. So we have already seen all these, basically all these architecture components in our Kubernetes series. And also we have a load balancer that helps in forwarding the external traffic to the cluster. Once you set a load balancer service. So in case of cloud, and load balancer will be automatically provisioned. But in case if you're managing the Kubernetes cluster by yourself within your own environment, so if you put a service type as load balancer, it won't work, because basically load balancer should be available and an IP address should be given out in order to manage the external access. But in case of cloud managed, of course, a service type of load balancer will give you an external IP address. So there are multiple Kubernetes distributions. So some are managed by cloud. You can also manage them yourself. And coming to the cloud managed, you have EKS by AWS, Azure Kubernetes Service by Microsoft, and Google Kubernetes Engine by Google. And also there are external tools that helps in easing the process of the creation of the clusters like kops. And coming to the self-managed, you have OpenShift by Red Hat and Docker Enterprise. For your local dev and test environments, you can use Minikube, so which is commonly used. Of course, you have micro-K8s and kind also. And we also have vanilla Kubernetes, which is the core Kubernetes project. So using kubeadm, we can set up vanilla Kubernetes. And there are some special builds like K3s by Rancher, which is very lightweighted Kubernetes distribution for edge devices like Raspberry Pi, etc. How coming to the managed, so we said that cloud clusters are managed clusters. So in managed Kubernetes, a third-party provider like your cloud providers like AWS, Azure and Google Cloud, so they take the complete responsibility of setting up the whole Kubernetes infrastructure and also operate them, like taking the backup, maintenance and upgrades. And also these managed clusters will have deep integration with other services such as their own load balancer services, virtual private clouds and storages, etc. So whenever we are requesting for any load balancer or whenever we are requesting for any persistent stores, so these Kubernetes clusters, so they call their own various services to provide load balancers and storages for us. In many cases, the managed Kubernetes means these master nodes are managed by the cloud providers. So we are going to manage only the worker nodes and all the applications that runs on them. But all the master nodes under the managed Kubernetes clusters are managed by their own third-party providers like your cloud providers. And coming to the Elastic Kubernetes service, so AWS EKS is managed service, which we already seen. So this lets you run Kubernetes on AWS without needing to create, operate and maintain your own Kubernetes control plane or worker nodes. So your AWS will take care of provisioning the servers, installing Kubernetes and also maintaining them, including the upgrade. So EKS is highly available. So we'll understand why we call EKS is highly available in some time. So here EKS is highly available with automated version upgrade and patching. So you don't have to worry about doing any version upgrades or patching because AWS takes care of this for you. But in case of self-managed, so we all know that we only have to manage the version upgrades and patching activities. And also AWS takes care of automatically managing the availability and scaling of Kubernetes control plane nodes. So so in the next slide I'm going to explain why the Kubernetes control plane nodes inside EKS are highly available. And also coming to the worker nodes, so worker nodes can be an EC2 instance or they can also be Fargate, which is serverless for containers. So AWS, as we said, AWS EKS manages the control plane nodes, and as a worker node we can create our own EC2 instances, or else we can also rely on Fargate profiles. And as we already seen, so when we come to managed Kubernetes services, so they'll have integration with their own AWS services. So in case of AWS EKS, so it has deep integration with ALV for load sharing, IAM for RBAC, VPC for pod networking, and also other services such as EBS, EFS, Lambda, SNS, CloudFront, Route 53, S3, etc. And this is how the architecture looks like. So basically this is not the architecture completely. So we have Amazon EKS, which is powered by Amazon EKS distro. So they have their own custom AMI for that. And coming to the worker nodes, you can have AWS Fargate, which is serverless for containers, or else you can have AWS EC2 instances as worker nodes. And we already know what is Fargate. So basically Fargate is serverless compute for containers. So that lets you run containers without needing to provision your clusters and installing any container runtime on top of it. So Fargate makes it easier to run containers. Basically it is a serverless solution. So with AWS Forget, you no longer have to provision, configure and scale virtual machines to run containers because everything is handled internally by AWS. So this removes the need for us to choose the server types and decide when to scale your clusters or optimize clusters, because Fargate takes care of creating the correct instances with correct instance types, and it will also know when to scale your clusters and knows how to optimize them. So Fargate lets you focus on entirely on designing and building your applications instead of worrying about managing the infrastructure. And coming to the EKS control plane, so as we know that Kubernetes has two set of nodes, one is the control plane and the other one is worker nodes. So coming to the EKS control plane, the control plane consists of at least 2 API server instances. So if you are setting up your cluster using kubeadm, we know that it creates one master by default, and inside one master you have one API server. But in case of EKS, your control plane will have 2 API server instances and 3 HCD instances that runs across 3 availability zones within a single AWS region. So this is to ensure highly availability. So 2 API servers and 3 HCD servers, they will run across 3 availability zones, and AWS automatically makes sure that it replaces unhealthy control plane nodes. So it detects any unhealthy control plane nodes and automatically replaces them. And coming to the Kubernetes API, so this is exposed via Amazon EKS endpoint. So we know that in order to talk to the Kubernetes cluster, we need to have Kubernetes API endpoint access. So in case of EKS, so EKS will have its own EKS endpoint, and data stored by HCD nodes and all the associated backend EBS volumes are encrypted using AWS KMS. And coming to the worker node, so EKS clusters can schedule pods onto a combination of self-managed nodes, so which we call them as EC2 instances. As we already said, your worker nodes can be Fargate or EC2. So coming to the EC2 can be self-managed, which means you manage the EC2 instances, or it can be AWS managed, so we call them as node groups. So they can be EC2 self-managed EC2 or EKS managed EC2. Our third solution is AWS Forget, which is serverless solution for containers. And in order to use EKS, so first we need to create an EKS cluster either through console or tools such as EKS CTL. So we have a dedicated section coming in the next videos, in the upcoming videos about what is this EKS CTL and how to use to create cluster. So once a cluster is ready, you can launch. So this basically what you need to understand is when we say about creating a cluster, basically we are talking about creating the control plane. So once control plane is created, you need to add worker nodes. So worker nodes can be managed EC2 instances, like we call them as node group, or they can be AWS Forget. So we need to decide which one to choose. And once your control plane and worker nodes are ready, you can configure tools such as kubectl to talk to the cluster. And since we have now access to the cluster, we can run any application. And also coming to the EKS integration, so there is deep integration of EKS with other AWS services. Like all your API calls can be audited in CloudTrail. Authentication is provided through IAM, while authorization is provided through native Kubernetes RBAC. So we already know what is Kubernetes RBAC to manage basically authorization within your Kubernetes cluster. And CloudFormation to manage cluster, basically, so when you try to create a Kubernetes cluster either through EKS CTL or management console, you need to have a combination of private and public subnets. So creating them manually will take some time. So internally, EKS uses CloudFormation templates to automatically create and manage clusters. And also it has deep integration with load balancer to create load balancers, EBS volumes, EFS to manage the load balancing and persistent stores. And it also has access to container registries, which is AWS ECR, and networking is handled with per pod IP address with attached CNI. And coming to the creating EKS cluster, so we can create it using management console, which is basically not the straightforward way, but you will understand what are the various components to be created in order to successfully provision a cluster. And this process will be completely automated using EKS CTL, which we'll understand in the coming sessions. And also, of course, you can use AWS SDKs or Terraform or Ansible scripts to automatically provision EKS clusters. And there are certain prerequisites that are required to create an EKS cluster. Like you should have an AWS account, and you need to have a system where tools such as kubectl, AWS CLI, EKS CTL are installed. And also, since we use EKS CTL, which is a command line, so it is better to have an IAM user with programmatic access, just to be on the just to ensure security of your AWS account. So that's it for this video. In the next video, we'll talk about how to create IAM users, how to install tools such as kubectl, EKS CTL, and AWS CLI. In the third video, we're going to understand how to create EKS cluster using AWS Management Console. Thank you, and I'll see you in the next one.